a perfectly horizontal line. If we have a horizontal line, is that going up and down or left to right?
Up and down.
Left to right.
Left to right, right? Like think about your x-axis. That is a horizontal flat line. A perfectly horizontal line. I'm just a mess this morning. It's okay. Always has a slope of zero. A perfectly horizontal line always has a slope of 0. After you get that written in, go ahead and glue in one of these little graph squares for me real quick. Oh, sorry.
You need glue.
There's no glue in there?
No.
Are you sure?
Yeah.
Okay. Let's do that then. My bad. Thought I could do it. If any of your glues are dead, just let me know. I can get you a new one. Thanks, sir. There you go. Supply box. Okay. Everyone got glue now? Okay. So we're going to glue this in. Right underneath, and we're going to see why, in fact, a perfectly horizontal line is going to have a slope of 0. We can already visualize why this is the case, because like we all repeated so enthusiastically, me walking on a flat surface requires 0 effort. Yes? So if we've got a flat surface or a horizontal line, our slope's going to be 0. Yes, I know you guys didn't get the squares. Okay. Yes. Hold on to those. You're going to need them later anyway. You're going to need those in a bit. I'm getting a second square passed out just to get ahead of it. Just don't glue the second one in just yet. We will, but not right now. I'm going to take it slow. Boom. Okay, so just hold on to that second graph square. We'll glue it in a bit. Let's go ahead and plot the points. Five, comma, 6. And negative 4, comma, 6. Using your rulers, connect those 2 points together. And you'll see that we've just graphed what type of line here. Starts with an H. We underlined it. Horizontal, right? It's flat. A flat line. Anyone ever seen like a Grey's Anatomy type show or like any of those like doctor medical shows? A couple people. If you have, do you know what a flat line is?
Yeah.
What does a flat line mean? When someone's dead, right? Exactly. So you have a little machine in the hospital that goes like beep, beep, beep. It monitors your heart rate, exactly as I was saying. So if your heart is not beating, you hear beep, and it turns into a flat line. That means you have 0 life left, right? So it's 5, 6. I think you did 6, 5 at that point. Yes, so over 5 and then up 6. Should be a perfectly flat horizontal line. So whenever you think of a flat line, you should think of 0. This line here has a slope of 0. But let's figure out how we can tell for sure that that's the case using our slope formula. y2 minus y1 over x2 minus x1. So let's label them just like we did yesterday. What can I call 5? What? X1, good. What can I call 6? Y1. What about negative 4? X2 and positive 6? Y2. I'm going to zoom in here a bit. Bless you. So y2 minus y1, 6 minus 6 over x2 minus x1, negative 4 minus 5. All right? I'll give you guys a second to catch up to that. Can someone help me out? On the bottom, if we have negative 4 minus 5, what do we get? Negative. It's negative? Negative 9, right? Think about spending $4, then spending $5. You spent $9 total. Now, what is 6 minus 6 going to give us on the top? 0. 0. Yes, sir. Would it be 1? The numerator, 6 minus 6? Oh, the fraction itself? Good question. No. Whenever we have a 0 on the top, it doesn't matter what we have on the bottom, our answer here is always going to be 0. And let me show you why real quick on the board. This might make some sense. This might help a little bit. We have 10 over 5, right? What would that be equal to, Devin? 2. Perfect. So what this division problem is saying is that our denominator, 5, times something is equal to 10. Right? So the denominator times something equals the numerator. So let's follow that same process here. My denominator is negative 9 times something equals my numerator. What was my numerator there? 0. So 9 times what is going to give us 0? Well, the only thing that can go in there is 0. You see what I mean? So if our 0 is on top, we know that we're going to have a 0 for the answer. It doesn't matter what our denominator is. If 0 is on the top, our whole fraction is equal to 0. Right? And we can even look at this graph in terms of rise over run. If we start on the leftmost point, how many units are we going to rise? Zero, right? We don't have to rise at all because they're on the same line. We just have to run over 9 spaces. Hopefully that makes some sense. If not, we'll get practice. M is equal to 0 is what we get. Any horizontal line, doesn't matter where it is on the graph. If it's perfectly horizontal, our slope is going to be 0. But we can use the slope formula that we learned yesterday to be sure and to figure that out. Give me a thumbs up if that makes sense. Uh-oh.
Oh.
Makes sense to 5 people. That's okay if it only makes sense to 5 people. We'll figure it out. Let's move on. Now let's talk about a perfectly vertical line. And whenever you see a perfectly vertical line, I want you to think of that treadmill that was going straight up and down. Would it be possible for us to walk on that treadmill going straight up and down? No, it would not. So a perfectly vertical line always has a slope of undefined. I know that's a little bit weird for our slope to be equal to a word. But what undefined means in math is essentially the same as impossible. Okay? It would be impossible for us to find the slope of a perfectly vertical line in the same way that it would be impossible for me to start walking directly up the walls, right? These walls are all perfectly vertical. That would be impossible. So get your second graph square glued in right under this. We're going to take a look at what that looks like and how we can find that out for sure. And we're going to plot the points 5, 5 and 5, -7. Using our ruler, we're going to connect those points up. We should get a perfectly straight up and down vertical line, just like that. Give you guys a few moments to catch up to that. Then we'll talk about it.
Thanks,
We're almost done.
Oh, okay.
Let's go through and label our coordinates. This is my first point here, 5, 5. So I'm going to label this x1 and y1. My next point, second point, 5, -7 is going to be x2, y2. Thank you. We're going to do the same thing. Plug this in. y2 minus y1 over x2 minus x1. What was my y2 again? -7. What's my y1? 5. x2 is equal to 5, and x1 is also 5. Whole lot of 5s there. Now we can solve and simplify. What is -7 minus 5? -2 is close. -12. In reality, it doesn't matter. And we'll see why in a second. But just to practice our skills here, I want to make sure we got -12. -7 plus 5 would be -2. But if you spend 7, then spend 5, you spend 12. What is 5 minus 5 though? 0. So this looks a little bit different than what we had up top, right? On the top we had 0 over -9, but now we have -12 over 0. Anytime we have 0 in the denominator, it's not just the numerator actually. Anytime we have 0 in the denominator, our answer is undefined. I know that's a little confusing, but I'll show you what I mean in a second. You're going to hear this phrase multiple times throughout your life. You cannot divide by 0. Okay? You cannot divide by 0. Now, I'm just a human, right? What do I know? But let's ask this calculator. What is -12 divided by 0? Right? Just like we found a fraction of -12 over 0. When we hit enter, we get an error. We cannot do it. It says error dividing by 0. So I'll say, okay, quit. The answer is literally error. You cannot divide by 0. So error is, just a calculator word, but we're going to use the term undefined. Imagine this line here was a treadmill. Would you be able to run on that treadmill? No, you would not. It is impossible. So finding a value for our m is also impossible. Think about me walking around the room. How much effort would it take you to walk on a flat surface like this? 0 effort, right? So if we're walking on a flat surface, 0 effort, our slope will always be 0. But it's not possible for Mr. Church to put his feet up on the whiteboard and start walking straight up the wall, right? That idea is undefined or impossible. Now if we plugged in 0 divided by -9, like we had in the first example, we get 0. 0 over 1,000,000, I think that's 1,000,000, is also 0. 0 divided by 0.0005, very small number, that's also 0. No matter what, when 0 is on the top, our answer is 0. But we could do anything we want divided by 0, and we cannot do it. It will give us an error. It will be undefined. All right? We could go into the reason as to where this undefined comes from, why you can't divide by 0. But I don't want to overcomplicate things and confuse you even further. So, something we have to remember, the main idea here, flat line, slope of 0. Walking on a flat surface, 0 effort. Yes? Vertical line, impossible to find the slope. Walking straight up a vertical wall, not possible. Give me a thumbs up if you're following that logic at least a little bit. Okay, when in doubt, and this is what we're going to do on our worksheet, we're going to use our formula from yesterday. Okay? So if the treadmill doesn't make sense, the mountains and the hills don't make sense, if that all jumbled up in your brain and confused you, I know for a fact you know how to use the slope formula from yesterday. When we see a 0 in the numerator, our answer is 0. When we see a 0 in the denominator, our answer is undefined. And if you forget which one is which, at least you have these notes at your disposal whenever you get the chance.